Correct. Correct. No, wrong. Drop the minus. Correct. Integrate 12t to the 7 minus t squared minus t plus 3 dt. Correct. Integrate 10w to the 4 plus 9w cubed plus 7w dw. Correct. Evaluate the integral of z to the 6 plus 4z to the 4 minus z squared dz. Correct. Determine f of x given that f prime of x equals 6x to the 8 minus 20x to the 4 plus x squared plus 9. Correct. Determine h of t, given that h prime of t is t to the 4, take t cubed, add t squared, add t, take 1. By indefinite integration. Gotcha. Right, okay. That was just a warm-up. Now the shape of a graph. Part 1. The intervals on which the function increases and decreases. All right. The question is, do I make them open intervals or closed? Or half open? Let's think about the definition. They would be closed based on that, I believe. We'll open up the solutions now. Well, just the first 10. Okay, so increases. And decreases. That's what I believe, but we'll see. Okay, so these are, first of all, just to assume that the domain of the function is the whole of the real numbers. But the most important thing is that the endpoints aren't included. But why actually is that? Yeah, for infinity, that's understandable, but why not these guys? I need to understand that. Given any x1 and x2 from an interval I, with x1 is being less than x2, but it is the case that f of -3 is less than any f of x within that interval, which is strictly greater than it. So I do not understand. I need to get to the bottom of this. Right, so first I'm going to check and see if he has this same policy here. Oh, he appears to. Okay. Then I'm going to look for definitions elsewhere and see if they agree with his. Right, so we want a good source for definitions. And my go-to for that is Proof Wiki, because they are intensely fussy about definitions, if anything else. Mm-hmm. Mm-hmm. Yep, I do not understand why these intervals are open. Okay, so what I'm going to see is I'm going to see other people solving this problem and see if they have the same sort of thing going on. Mm-hmm. Increasing on these intervals. Notice they have them closed here. Okay, so that agrees with me. And so now, that does not mean that I'm right, but instead that means I'm in a state of confusion because I have two sources that I reasonably trust, and there's a conflict. Okay, this source Geeks for Geeks tends to be pretty good. All right, now what I'm going to do is create a problem for which I already know the answer, like a cubic. So a cubic with roots that I come up with. So I'll say, I already know that the roots of this cubic are going to be -3, 0, and 2. And what I'm going to do is ask the quote-unquote thinking models of 3 of the LLMs to see what they answer. And if they all line up, then I know that this is more typical, I guess. Okay, and those 3 LLMs are GPT, Gemini, and DeepSeek. Okay, so GPT has open intervals. Gemini has open intervals. And DeepSeek, well, DeepSeek's not finished yet. So what I'm going to ask them then is, okay, DeepSeek is just finishing. And those are open intervals as well. Okay, also, I don't know why I was talking about roots. The roots of the cubic aren't relevant to it being increasing or decreasing. What's relevant is the maximum and minimum. So I don't even know why I was saying that. That was just false. But anyway, it will be a cubic that has a kink in it, which is exactly what I'm after. So, but it uses open intervals as well. Okay, so now I'm going to ask, right, so all right, let's consider another function. Yeah? Something which is kind of easier to understand and picture, because this one has messy maxima and minima. Let's consider sine of x for well, let's say minus pi to pi. Increase, I believe this is increasing for, wait. Minus pi over 2 to pi over 2, closed interval. That's what I think. But no, if I do that, it'll say, "Oh, you're right," and and I want it to just explain it to me, but explain yourself. And the reason why I'm doing this is because I've looked at the definitions and I can't understand that. Okay, so there are two common definitions. There's strictly increasing and non-decreasing. Okay. Okay, I get it now. Okay, there's two conventions at play. There's non-decreasing and then there's strictly increasing. And what I've got to assume is strictly increasing. All right. Okay, and the intuitive way to think about it is to consider that the function isn't changing at these points. And so if something isn't changing, you wouldn't say that it's increasing or decreasing. That's how I can sort of wrap my head around that idea. Right, so I understand now. These are open intervals, and also we're just to assume the end behavior of the function. In other words, that it keeps on increasing that way and it keeps on increasing that way. So I'll put infinity there and negative infinity there, and I'll use round brackets, and that's good. Next, we have this. And here are the turning points. Well, that's like an inflection point there, right? Okay. So increasing from minus infinity to 1, decreasing from 1 to 4, increasing from 4 to 8, and then it stops, and then it begins again from 8 to infinity. That's what I believe, but I'm about to see. Oh, I just did that one. I'm about to see if I'm correct or not. Okay, good. That's correct. Problem 3. Below is the graph of the derivative of a function. From this graph, determine the intervals on which the function increases and decreases. Okay. Okay, so negative derivative here to here. That's another important one. And here. Okay. Right. Just say what you think and then see. All right, so I think it's decreasing from negative infinity to negative 7 because the derivative is negative. And then it's increasing from negative 7 to negative 2. And then it does nothing at negative 2. And then it continues increasing. And then it starts to decrease. But let's see if that's right. Right, okay. Yep, that's correct. Okay, that's good. Okay. This problem is about some function. All we know about the function is that it exists everywhere. Answer each of the following questions about this function. Well now. What a whole bunch of information. Let's graph it. Okay, so the numbers go from -5 to 8. So, how to get a piece of graph paper? Go here, GeoGebra. Use your screenshot tool and grab a piece. And then put it in. There you go, that's nice. All right. That's going to be my f prime. Now, at -5, as in here, it's going to be 0. Okay. -2, it's 0. Okay. At 4, it's 0. Okay. And at 8, it's 0. Okay. Now, it's negative from there to there. So I'll just do that. From -2 to -4. Okay. So I think what they mean to say is that it does this. Just touches it. And then there, like that. Then it cuts through there. Then it goes back down to being negative. And it's greater than 0. Past there. And that's how it looks. So, what are the critical points of the function? Critical point. To be a critical point, first, we're going to call you C. Now, first, f of c must exist. That's necessary. And the function is that it exists everywhere. So everything is potentially a critical point. All right. Now, what next? Either f of c, f prime of c is equal to 0, or f prime of c does not exist. And therefore, I think critical points are there, 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 and there. Part A, I say -5, -2, 4, and 8. And let's check. Okay, that's correct. Determine the intervals on which the function increases and decreases. All right. Increases, decreases. Okay, it increases for this part and this part, I believe. and it decreases for this part, and this part. So I say -5, -2, and -2, 4, and 8, infinity. That's correct. Classify the critical points as relative maximums, relative minimums, or neither. Okay. Right, let's think about this logically. What does a maximum look like? A maximum looks like that. And if you're on a roller coaster cart, f prime is positive, then tells me, what does that tell me? That tells me that that's a max. And so is this one. And the opposite would be a relative minimum. So this one. And this would be neither. That's what I believe. So we're about to see if that's correct or not. Okay. That's correct. And that's good. Now comes another polynomial. Increases and decreases. And then classify the critical points as relative maximums, relative minimums, or neither. So get to work. Divide through by 6. Factor. Solve. Good. Next. What does the derivative look like? Positive quadratic. -5. -2, 5. Like that. And what else? Now answer the actual question. Critical points. -2 and 5. increases from negative infinity to negative 2, 5 to infinity, decreases negative 2 to negative 5, and classify the critical points. So what I'm going to do is do parts A and C together in the future, if I can. Hold on now. There. Check. Correct. 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 Next. Differentiate. (120t squared minus 20t cubed minus 20t to the 4). Why am I saying t really weird? Because of this. This sounds exactly like this number, which is a problem when you're reading out mathematics for people. So I say it's strange on purpose. Solve. Set that equal to 0. Divide through by 20. So, and t squared. And how to actually do this? This always throws me off when they're like this. But how about that? Okay. Wait, is that right? Yeah, that's right. T is equal to -3, 0.